Today I want to demo some technology that we've put together and talk about some things that we've been working on to look at ways that organizations can reduce the time that they're exposed to vulnerabilities. If you've kept track of the data from like the White Hat folks, the Veracode folks that are releasing data about like the lifespan of vulnerabilities, you see that a lot of organizations they do a great job of finding vulnerabilities. They often don't do as workmanlike a job of fixing vulnerabilities. And when you combine that with the fact that in a lot of organizations, at least some of the infrastructure that they have, or even a lot of the infrastructure that they have, there aren't necessarily strong controls about what code gets put out there. Puts you in a situation where organizations can end up with a tremendous amount of exposure from their web-based systems that they don't necessarily know about. And so what we're going to look at are some techniques that we've been playing around with to try and automate at least the short-term functional remediation of these types of vulnerabilities. Again, I'm Dan Cornell. I'm the founder CTO of Denim Group, and my background is as a software developer who's focused on security. And again, did a lot of work in server-side Java, and then spent a couple years doing .NET stuff. The last, however many years, 7 years or so, been focused on security. And so that's my perspective. And I'll really admit, I don't come from a really strong security operations background. And so that's one of the things that we're pushing to do with this technology that we've developed, is to start to get feedback from folks that maybe attended these techniques, who are interested in rolling out or beta testing these types of techniques. So please feel free to track me down, and we can talk about this stuff. Again, Denim Group is a background. Denim Group is a firm that develops secure software and helps organizations deal with risk associated with their software. And so a very software-centric view of application security. It's the cloud, right? How many people came to this talk because it had cloud in the title? We'll skip this slide. So sorry, the devil made you do it. The devil on me. So that's a little bit of a joke, just because cloud is such a buzzword. But as we'll see, the way that we've looked at these techniques, they are, or at least the way that we've worked on them. The idea is how can you automatically start to deal with some of the risk associated if you have private cloud, if you're a service provider and you're providing things, platform as a service, certain aspects of software as a service where you have extensions and things like that. Any situation that you have where you have infrastructure and you don't have tight controls over what necessarily gets deployed in that infrastructure, these types of techniques we think could help there. How many folks in your organizations there aren't great controls over all of your infrastructure and what gets put out there? A couple folks. And so as we'll see, there's a couple pieces of this. There's a couple steps in what we're talking about, and the steps you can kind of break apart into different pieces and use just portions of it. And so we're going to look at kind of all the way through from this uncontrolled infrastructure. How do we deal with this and shorten the vulnerability exposure window that you see. But again, you can kind of chop up and just use portions of this as well. And you can all take comfort in knowing that I haven't mentioned the advanced persistent threat yet. So, in your organization, who's your worst enemy? Is it your software developers that are building stuff, or is it the bad guys that are attacking your stuff? Or as Colin says, is it marketing? How many people think that your developers are your worst enemy? Yeah. How many people think that bad guys actually do the attacking or your worst enemy? I guess an important point to make is the bad guys are ultimately your worst enemy, but in a lot of cases, developers aren't necessarily helping you do what you need to do. But again, I take a developer-centric view of a lot of this stuff, and so you've got to defend the developers. Most developers are happy to write secure code as long as you teach them how to do it, and then actually give them time to do it. Most organizations and the way that they the management structure and the the incentives for development teams, and all of these things are lined up so that you don't see a strong incentive for developers to build secure code. I was giving a talk about mobile app security stuff at B-Sides Austin. And a question along the way, so somebody said, like, you just need to beat the crap out of those stupid developers. Wow. I was like, all right, well, that's a security guy that is, like, he's spoken the last word that's ever going to be heard by anyone on his development team, right? Because when you come around, you're like, oh, you stupid developers, you scroll this stuff up. It's like, with the Peanuts teacher sounds like, wah, 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 wah. And so, again, developers are certainly contributing to the problem. Ultimately, you've got to worry about the attackers. And so what we're going to look at here are ways that in the absence, or as you're putting controls over what gets deployed in your environment, what are some things that you can do to help keep certain classes of attackers at bay, and to, again, kind of reduce your risk window. The problem that we see in a lot of organizations that we work with, in a variety of types of organizations, but they have some sort of infrastructure, right? Either it's a data center, multiple data centers. Maybe they have a public cloud that they've got some assets on, and people have the ability to deploy new assets on. Maybe it's a private cloud. But the problem is a lot of the organizations that we work with don't have great controls, or at least not consistently enforced controls over all of these assets where folks can expose them to risk. As we see with the cloud, there are a lot of problems with organizations. Like anybody with a $500 limit credit card is all of a sudden like their own purchasing department, right? So like all the stuff that you pay, all the controls and stuff that you pay, put out there, people can go around and find ways around this stuff. And so what we see are, because the organizations are exposed in a variety of ways, these attackers trolling around with automated traffic. And again, we're not talking, I'm not talking here about very dedicated attackers, right? Like if anonymous decides they really want to beat you up, this is you've probably got other problems. But what we see are these automated SQL injection worms trolling around, sending junk traffic at sites, and looking for things that have strong signatures, and so they're easy to automate the discovery of things like SQL injection, things like cross-site scripting, other injection type flaws. You see these vulnerabilities exposed in applications. They have strong signatures, and so these are the types of things that the bad guys are going to be able to find in an automated way, and in a lot of cases, they're going to be able to exploit them in an automated way. And so you don't have to have someone that is specifically focused in on your organization, but you're in trouble simply because you have something deployed and because it's exposed out on the internet. And so, again, to what end does this allow attackers to advance whatever goals they have? Again, it depends on the goals, but the unfortunate state of the world is that most public-facing web properties are going to be exposed to this type of hostile traffic. And so the proposed solution, or what we've been looking at, is how can we automatically identify newly deployed code? And this could be either entirely new applications that have been deployed. If somebody spins up a new server, new app server, provisions, hosting, whatever, and turn something on, or even deploying new versions of old applications, but putting code out into production. How can you identify in your environment that these types of events have occurred? Because when those changes occur, that's when you have that's when you have a situation where the security state of the system, as it was before, is not necessarily the security state of the system that there is now. So once you've identified this newly deployed code, then looking to figure out how can we identify these vulnerabilities that are likely to fall, that are likely to be identified by this type of hostile traffic. Once you've identified those vulnerabilities, you know what your exposure is, right? So hey, we've got application N+1 has been dropped into our environment. We know that we've got some set of vulnerabilities out there, and how do we, if we know that we've got these vulnerabilities, how do we protect ourselves for these specific vulnerabilities where we know we're exposed to risk? And again, this is something, if you look at the data from the Whitehead report, the Veracode report, looking at these vulnerabilities, even if you know about the application, right, and you've had someone come in and assess the application, you've identified these vulnerabilities, even in situations like that, organizations are doing really crappy job of closing this window of exposure. A huge problem in a lot of organizations that we work with is like they don't even know, from an inventory standpoint, they don't even know the assets that they have exposed. And so, so how do you protect? How do you protect what you don't know you even have? It's kind of an impossible problem. And so, like there's some other solutions that fit in this. There's other ways to solve these problems, which may or may not be acceptable or ideal in your environment. This is certainly an area where web application firewalls, if they're in blocking mode, can provide value. But a lot of organizations don't necessarily have a web application firewall. So we see organizations where the code changes too frequently, or things are deployed too frequently for the WAF to sufficiently get trained up. We see a lot of environments where the WAF was turned in blocking mode. Like maybe it got trained for a while, they got turned in blocking mode, and it like blocked the senior VP of XYZ's trying to order flowers for his wife or something like that, and then all of a sudden the WAF is back in learning mode, right? Like we see way too many situations where organizations have deployed a WAF that feel like that is that's their great mitigation step, but nobody actually goes and checks to see, hey, is this WAF actually blocking traffic, right? Or even does anybody look into the logs for this stuff? And we do a lot of vulnerability remediation work. I can think of a specific instance. It was a year or two ago where the decision was made. We said, hey, we're going to fix these vulnerabilities in code. There's too many vulnerabilities. It doesn't make economic sense to fix these other vulnerabilities. Right? So we're going to rely on the web application firewall technology that's been deployed. Like that is our acceptable remediation. Instead of fixing the code, we're going to rely on the WAF. Ideally, we fix all the code, but honestly, there's too much code to fix in this case. We're going to rely on the WAF to do this. Auditor comes back around on whatever their cycle was, finds the same vulnerabilities that that they were supposed to be fixed. We get the angry phone call saying you guys said you fixed this stuff. We said no, this was supposed to be handled by the web application firewall. The operations team had to put the web app firewall into blocking mode, and so the best laid plans of mice and men. In certain environments, either because of inattention or intentionally, WAFs are not are just not used in this way. Another option would be to know when things get deployed, to find vulnerabilities, and then to go and fix the code. Right? Is that the right way to do things? Right? You find vulnerabilities, you make changes in the code, you push it live, and then you no longer have vulnerabilities in the code, and you can move on to your next thing. How many organizations are really jumping on that real quick? Everybody know, and that's why you see the numbers that we see from the White Hat and Veracode folks, and because folks don't identify the vulnerabilities, and when they do identify the vulnerabilities, they don't fix the code. Or as in another remediation project that we worked on, we fixed the code, no one bothered to push it into production. Again, angry phone call. Hey, you guys said you fixed this stuff. We said we did. We checked it into the source code repository. We can't touch your production servers. And so again, that would be in an ideal world, or in a more ideal world, that may be the option that folks look for, is active scanning programs, assessment programs, and then prioritization of fixing these things. But the challenging thing, and Mark Kerfrey mentioned this in his keynote earlier, is features defeats performance, and performance defeats security, right? And that's almost across the board for organizations. The way that they make decisions, there's not a high priority placed on making these security fixes. And honestly, really the way you got to do this is not introduce vulnerabilities in the first place. Yeah. How many organizations have taken that approach? Right? There we go. That's and so there are other options, and again, we're kind of exploring the use of these techniques and how these can be mixed and matched. And we'll talk about we'll see in the example data that we've got later from the experiments that we've run, how some of that stuff works. And so there's a couple ways that we've looked at identifying newly deployed code. You can wait around and wait for the application development teams to notify you, hey, guess what, we're putting things out in production, right? Is that, again, ideal world, happy world. We've also played around with scanning the network space. Is that something from an asset management standpoint? That's a program that we do see organizations, or some organizations have in place to say, okay, hey, do we have a program to say, when do new IPs come online? right? When to do ports, like how do we dip those from day to day? And so that's useful because if you start to have that kind of insight into your environment, you can identify events where you say like, hey, I used to have 100 applications deployed, now I've got 101 applications deployed. Well, what are we going to do? And we've also looked at doing some monitoring of files and directories. And again, depending on how your infrastructure is set up, if you're watching, Apache configuration files, if you're watching where new code and stuff gets deployed, you can also identify these events to say, the state of the files and directories have changed, or the state of this config file has changed. Like, let's go and find out what new thing or how the state of the system has changed because we might be exposed to new stuff. Identifying vulnerabilities. You could always do manual penetration testing. The problem is that it's really challenging to scale that, especially if you don't know, if you don't necessarily know what's deployed in the environment. Automated scanning is what we're going to look more in detail at, or manual assisted scanning. Running scans, looking at false positives, things of that nature. And then finally, blocking traffic. Like, because you're not in a position, or most organizations aren't in a position, or at least the window for a fix is not on the nature of like minutes or hours. It's typically measured in days, weeks, and months. What we're going to look at is like, how do you create virtual patches to block traffic that may be trying to exploit these identified vulnerabilities. And so you're creating very targeted traffic monitoring rules to look for, to identify situations to say, like, this traffic is going to a place where I know I have a vulnerability. I'm going to get very aggressive about blocking that, because in a best case scenario, this malicious traffic or this weird looking traffic is going to result in like an error message, right? If you got like a SQL injection vulnerability and somebody's last name is O'Hare or something like that. Well, if the code isn't set up to properly handle an apostrophe, in the best case scenario, you're going to get an error that gets kicked back. In the worst case scenario, that's an actual like attack traffic that's coming in, and so you block that. And the overall thing that we've used to do this is some technology that we've developed called BridgeFix, and it does a bunch of consolidation of vulnerability data from different tools. It integrates with IDS and OWASP, and that's specifically what we're going to be looking at. And it also helps communicate a bunch of stuff out to defect tracking systems. And this is going to be released open source here shortly. And so we're going to focus specifically on kind of the virtual patching stuff. And so, like, how do you connect vulnerability scanners to these intrusion detection, intrusion prevention, or web application firewall systems that you've got deployed? How many folks here in your organizations have web app firewalls deployed? Okay, a couple folks. How many folks here have more traditional like network intrusion detection, intrusion prevention stuff deployed? All right, so even more. And so that's one of the things that we'll look at is how do we leverage, these network intrusion detection, intrusion prevention systems, and update them so that they can be more relevant against web-based threats. And the example we'll use is Snort. And so what we're going to look at is, like, based on structured vulnerability data, how do we auto-create these rules? And what we can also do then is, like, once we've created those rules, we can monitor the logs and map the alerts where these rules fired, map it back to the vulnerabilities that were identified. And so what that can provide, is insight into not just into where we're vulnerable, but it can provide you insight into where are, what have attackers discovered, what are attackers, like what parts of our infrastructure or applications are interesting to folks that are doing the attacking. Because then that can help to prioritize or make a case for saying like, hey, can we not have another feature? Like, can this box not have to spin in the next release of the software? Instead, can we like fix the SQL injection vulnerability on the login page? So again, like having data, like where you say, hey, we're exposed to all this stuff, and guess what? These are the ones that are really getting hammered, right? So somebody knows about them. This is valuable. This is scary. Based on that data, then you can start to make like an actual, I call them like an adult conversation with management, right? If you go to management, you say cross-site scripting is scary, right? Neat. Right, but that's not a grown-up conversation, right? If you go to management and say like, hey, attacks on these known vulnerabilities have increased 50%, from like this level to this level. Well, all of a sudden that starts to be a much more convincing argument because it says like, hey, we know that there are people out there with malice that have identified our systems, and they are, this is a clear threat. and the protections we have in place aren't necessarily going to last forever. And so, we need to allocate resources to fix this. So specifically, what we put together here is for the code change detection, where we've set up a test lab, and I'll talk about that in a second. We set up a test lab, and basically we watch kind of known directories on this server that we've deployed, so that it can identify, hey, a new application has been dropped on top of Apache, right? The Apache config change and this directory change. Therefore, we have something new. But this could also be easily wired up again to network asset tracking systems, diffing Nmap scans or something like that. In our environment, just because we don't have we don't have like a giant test network, I have like 3 boxes strung together at the current time, to do exhaustive network scanning and diffing didn't really make a lot of sense. But that's a fairly straightforward problem, I think, to at least get us started solving. For vulnerability detection, what we do is we kick off automated skipfish, unauthenticated skipfish and W3F scans. And as we'll see, we can support any dynamic scanning technology. We can do this with AppScan results. We can do it with Burp Suite results. We can do it with anything that will produce structured vulnerability data for us. The reason that we picked skipfish and W3F was that those are open source, and so if people want to play around with this and replicate the stuff that we did, you can do that. You don't have to, other than having a couple boxes, you don't have to go license something, or it's not tied to a specific thing. For blocking traffic, what we've done is we've created rule generation rules, snort, and for mod security. And again, the goal here is to use commonly available, common and freely available technologies, because number one, what you see is with snort rules and increasingly with mod security rules, those can be used potentially across different blocking technologies. That's something the mod security folks have done recently. Is they've got a compatibility specification talking about hey, if you can support rules like this part of our rule language, then your WAF can consume our rules, and that rule language then is something that again, you don't have to code rules for every different blocking technology if the blocking technologies all understand the same rule language. And the same thing with snort. Snort is how many folks have some sort of a snort or snort variant running in their environment? Again, open source technologies so folks replicate and rule compatibility. And so one of the things that we spent a lot of time on is figuring out, for all these different detection technologies, right? All these different scanning technologies, what's the fundamental data that it's providing that gives you insight into the vulnerabilities you've got in your code? And so here we see skipfish data, which is a JSON. Folks have looked at this, and it's got a severity 4 type is this, an abstract. We map everything back to the MITRE CWE because that works across. It's a little bit more granular than the OWASP top 10 and the OWASP 26 or OWASP 42 or whatever OWASP is at these days. So that lets us normalize all this data back. And we see we've got the URL here where the problem is, and we see that injection points and things like that. If we move over here to W3AF, it's got XML file results. And we see post the type here, the OS command vulnerability. You see the URL, and you see the injection point there. And also just to look at IBM rational AppScan vulnerability data. We've got that issue type here is a blind SQL injection. It's got a link to some remediation content. And then you can see here's the URL and whatnot. And so one of the things that we did is normalized a bunch of these different products. And this is something we've been working on, some of this data manipulation for the last couple of years. And what we found is the initial kind of constructs we created have actually been really durable over time. And what we look at are 2 different things. For this dynamic assessment data, if you have a tuple of the vulnerability type combined with the vulnerable URL and the injection point, that is typically stuff that you can get out of any of the file formats for the major stuff that we've looked at out there, right? And so that lets you know I have a SQL injection vulnerability. It's in login.jsp, and the injection point is the parameter of username. Right, and so for injection type vulnerabilities, cross-site scripting, things like that, that helps you uniquely identify, at least for our purposes, uniquely identify a specific vulnerability. Also, for other types of vulnerabilities, and this depends on the CWE vulnerability type, It's sufficient to say, well, I've got a vulnerability type and I've got the vulnerability URL, right? I have a predictable resource location, right? I have login.php.back, right? So if I know that I've got a predictable resource location and I know the location of that resource, you don't have, like, for the vulnerability to be exploited, you don't have to, there's not an injection point that comes in at, like, a specific place. You just need to know, like, hey, this resource is here and it shouldn't be. Same thing with things like directory indexing and stuff like that. And so one of the things we found is for, like, all the providers that we've looked at, with one exception, we're talking to them about this, but, like, this is kind of the core information that you need to know about a vulnerability so that you can start manipulating this stuff and doing interesting things, right? Because it lets you do stuff like deduplicate results, right? If I have, if I've got skipfish results and W3F results, and I know for both of those that, skipfish calls something blind SQL injection, W3F calls it blind SQL injection, the capitalization is different or something like that, but we map both of those back to the CWE. The same thing. If we know that the URL is a specific thing, and the injection point is a parameter, username, parameter, password, that lets us say, these two tools found the same vulnerability. And so if this one found 10 and this one found 10, that doesn't mean I have 20 vulnerabilities. Maybe that means I've only got 15 vulnerabilities, right? And so that's one of the things that we spend a lot of time doing is that deduplication process, because that lets you, especially looking at using multiple technologies like this, different crawlers have different strengths. And there was a really good blog post, like somebody spent a tremendous amount of time. Has anybody seen this recently, the comparison of all the dynamic scanners? Yeah, I mean that person spent an incredible amount of time, going through all that stuff. Wow, and so, like, hopefully with the technology we built, that will make this type of stuff, like that type of analysis, easier to do in the future. To say, hey, I've got these 20 different scanners, we're going to pull all the data in, and we've got an engine that'll actually normalize that stuff. So what else do we need? One thing that I would like to see that we don't have a great way of getting consistently now is better information about the payload. Because right now, we're fairly aggressive with the payloads that we're creating, again, because we know we have a vulnerability. But in certain situations, like with SQL injection, was the payload able to, was it a problem because we had an apostrophe in there, or because we had a double quote in there, or because we had something else in there? And so right now, the signatures that we're generating could be slightly aggressive. So that would be great. That's something that, like, you see things like AppScan has, like, different variants. They say, well, here's the vulnerability, here's a bunch of variants. And so some of the folks have that data, other scanners don't. So if we look at and again, like, once you've got this structured data, then you just need a language to express what traffic looks like, and you can start creating your stuff. So here's an example. Snort rule where we're saying, like, drop packets from here to wherever. Snort has some constructs, not as powerful as, like, mod security, but Snort does have some constructs that let you, like, break down to, like, slice out a piece of HTTP traffic and target certain things, and then, basically we've got regular expressions that say, this is what I think a SQL injection attack might look like. Here's an example mod security patch. Again, different rule language, but given the data we have about the vulnerabilities, once that's structured stuff, it's just running a really simple transform. And we've got two different approaches that we've talked about for these virtual patches. Either saying, here's the vulnerability type and here's the vulnerability location. Right? Hey, there's a reflected cross-site scripting vulnerability in this parameter on login.php. Or you can say, here's what traffic looks like that's scary, and here's the location that I don't want to see this traffic going to. Watch out for HTML-ish characters that are being sent to login.php and whatnot. The approach that we've got right now for these for the Snort and the mod security stuff follow the second approach, right? Because they don't, in interior, they don't necessarily have an idea of this is what a SQL injection attack looks like. When we've talked to some of the commercial vendors that we're looking to support, they prefer the first approach, right? Like, hey, we've got our magic where we know what we know what we think a SQL injection vulnerability looks like, and so just tell us where it is, and we'll augment our training with that with that information. And so the standard that we use when creating this stuff is basically like if the scanner shuts up, we assume the vulnerability is fixed, right? And that's not true. And so but basically the process we went through is like, let's tweak the detection payloads until we've got the case for all the scanners, but we've got to be careful for overly aggressive stuff. And again, I know everybody's going to say is like, it doesn't mean it's actually fixed. That won't stop the advanced persistent threat. You're right. But that's not necessarily what we're trying to do here, because what we're looking at is for things, right now at least, we're looking for things that can be discovered in an automated way. How do we make it so that those things won't be discovered in an automated way and won't become a target for attack? Test environment is real straightforward. It's got a scanner and a rule generator. It talks across a box that's got the Unix in it, and it runs the scan against the web app. And so the process we run through is detect when something changes. That alerts the scanner. It runs the scan, generates rules, puts those on the sensor, hubs the sensor so it reloads rules, and then reruns the scan. And because of this diffing technology, these diffing routines that we've written, you can look and see, well, yeah, when we first did the scan, there were this many vulnerabilities as far as the scanner knows. The second time we did the scan, there was only this many vulnerabilities. So I'll just do a quick demo. And so, basically what you log in. You can pick the way that you want to handle the traffic, right? So, like for the blocking stuff, you may want to turn it in blocking mode. You may just want to turn it in alert mode. And the demo video's not working for me, which is great. There we go. It's running. Okay. And so what this does here is, like basically we've got a script, so we can script this all via web services. So we can make a call in and say, create a new, detect a new application, create it in the system, attach it to this type of sensor that we know it's behind. I'm going to run a scan, toss the, once I get the results of the scan, toss that back into the sensor, pump the sensor so it reloads the rules. Those are the rules that got generated there, and then it reruns the scan after that to confirm or deny that the fixes actually worked. And I can, if someone wants to see afterward, I can show you a better fidelity demo of this stuff. So we've got results for Snort and mod security. What we saw with Snort, basically, we started out finding 20 things from Skipfish, 10 things to 3F, and they found different stuff. After we ran, once we generated rules for ThreadFix, we actually shrank the number of things from 20 to 10. Like all vulnerability types can't be remediated this way. This lends itself to injection type things, cross-site scripting, things that have that strong type of signature, which also thankfully tends to have a strong type of signature for protection. An interesting thing here is like W3F doesn't like it when Snort is dropping packets in between there. Like it actually like the scans don't do it. That's I think none of us can track this. For mod security, what we did similar stuff here, where we're in Skipfish and W3F, and what we did is we looked at this in two different ways. We looked at mod security just as a blocking technology, but we also baselined it against the mod security core rule set. Because like virtual caching heat and all of that, if you can just like throw the core rule set in front of something, okay, well, like why would we put all the trouble? Another interesting thing is that the Skipfish, with the core rule set inside of there, actually detects additional false positives when it's run against a sensor that's running the core rule set. And so there's actually more vulnerabilities that get identified in certain cases, for mod security with the core rule set. And again, as you see here, we're able to go from a vulnerability exposure like this to just like that with ThreadFix, which is slightly better here for the technology that's not. We're able to block some injection technology. We're able to block some injection techniques that W3F, the core rule set currently doesn't do out of the box, and we're actually working with the guys to see. They did a really cool thing, which I've got a link to, I think here. Yeah, they did a really cool thing with their SQL injection challenge. Anybody participate in that or follow along with that? Like really cool stuff to look at, like how can attackers try and bypass these different rules? And so the IDS, interesting thing we found, IDS IPS WAF has an impact on the scanning process, which is cool. Snort breaks W3F, mod security CRS introduces false positives. Overall, the mod security CRS is really good, is pretty good, and so that may be an option for folks. Again, if you're like there may be concerns about false blocks and things like that. Where we had the biggest win, so far, is using virtual patching to address these the injection type flaws, where it's maybe too scary to block this traffic in general, but more acceptable to do, again, if you know that you've got a specific vulnerability in place. So immediately out of the box, this is interesting for environments where you have little or no control over the deployed code. So XYZ as a service, or all data centers. Or environments where you have a large application security dent, right? Where you're coming and trying to start a program and saying, you know what, hey, we just scanned our 500 websites, and we've got like all kinds of problems, and like how are we gonna like shrink our exposure in a very rapid, very short amount of time. The current problems, if you look at the data, vulnerability data formats don't kind of require us to have somewhat coarse-grained virtual patches. And when I talk about coarse-grained, I'm talking about coarse-grained from the standpoint of the regexes of the traffic that you try to block. Because there are a variety of different variants of like how SQL injection or cross-site scripting or something like that might be executed, and you've kind of got to block all of them to shut the scanner out. But that may be blocking too much because of the particulars of the code that this is being run against. Problems with this, virtual patches likely will not stop well-informed determined attackers. But a hope here is that against unfocused attackers, they're not going to be well-informed because they wouldn't have discovered these vulnerabilities in the first place. Right, like the window would have been closed on those. And again, I really recommend everybody look at the Mod Security SQL Injection Challenge. They got some really good data out of that on like the time it takes to discover these types of bypasses and things of that nature. Next steps, more data. This is currently being run against a set of target applications in our environment that are intentionally flawed. We're looking to expand that. We want to develop import support for more scanner technologies. And that's pretty easy. We've got it down where a basic import can typically be written in like an hour or so if you're running against XML or something like that. It takes more time to make sure you're covering all the CWEs and stuff like that, but you can get some really good results pretty quickly. You want to create virtual patch signatures for more vulnerability classes. The core rule set guys from Mod Security have some interesting stuff for like CSRF protection that works in the newer versions. We may look at borrowing some of the stuff that they're doing there, again, to provide these targeted solutions. And there's limitations on what can be done. You're not going to be able to block like authorization type vulnerabilities, but those are also the types of things that just get fished W3F or other things that are like, especially in an unauthenticated scan, aren't likely to identify. And the nice thing, we've seen point solutions for this before. They're really like a cool thing, I think, about what we've put together is that instead of having like a hub and this creates like a hub and spoke way of creating virtual patches where to support, you don't have to create each integration that you may want. You just have to create the, you just have to say, hey, if I've got a new import technology that I want to use, then I just have to write that. If I have a new blocking technology I want to support, then I just have to build the stuff for that. And all of this data is being brought in and normalized, which in this case is handy for virtual patching, and I think also for organizations that have like heterogeneous like scanning technologies that are being used, or multiple scanning technologies that are being used. It's helpful for that as well. And if you're interested in participating in the beta for this, let me know. Just send me an email if this is something that you're looking at that might be interesting in your environment. Again, we're excited to have this technology finally pushed out, and would love to have you complaining at us about what it needs to do to work better. Thank you all.